In this session here, we're going to be taking a look at multiplication. And once again, we're going to be addressing the very basics of multiplication as it started off in your earlier years. And obviously, as you progressed on, you learned the multiplication tables and performed some longhand 2, 3, and possibly even some 4-digit numbers being multiplied together. But to illustrate the very basics of multiplication, let's start off once again with the example of the apples. Here I have 12 apples going across the screen. I have a group of 3 here, another here, one more here, and then a last final group of 3 here. Perhaps the first way that you were introduced to multiplication is that it's just repeated addition. What do I mean by repeated addition? Well, we have 3 numbers, 3 apples in this group here. And what we're going to do is repeatedly add another group of 3 to it. So here's our first group of 3, there's our second group of 3, there's our third group of 3, and there's our fourth group of 3. And we're going to add these 4 groups together. That's what we mean by repeated addition. 3 plus 3 plus 3 plus 3. Well, if you count that up or add it up, you'll find out that your answer is 12. Another way of writing this repeated addition, though, where the same number is repeatedly being added to itself numerous times, is to do it through multiplication. And one way of visualizing or writing it would be, first of all, writing how many apples are there in each group. Well, we have 3 in each group. And then that's going to be multiplied by the number of groups that we have. Well, how many groups of 3 apples do we have? Well, we have 4. So we have 3 in each group, and it's being multiplied by 4 in each, or 4 groups in total. And we'll find out that 3 times 4 is 12. On the following screen, we'll go ahead and show you why algebra uses a different method for showing multiplication. But I went ahead and used the normal way that you've shown it up until this point, and that's just with a cross here, or with a symbol that looks like the letter X. So the first way to look at multiplication is repeated addition. Well, another way maybe to help visualize what multiplication is you take each of your groups and you stack them on top of each other. Here's our first group of 3. Here's our second group of 3. Here's our third group, and then our last group of 3. And if you stack them on top of each other, you can see that it makes a rectangle of sorts. How many apples are going across each row here? Well, we have 3 apples going across each row. So I'm going to write the number 3. And here's our multiplication symbol. And then we're going to multiply it by the number of rows that we have. Well, how many rows of apples do we have here? Well, we have 4 rows. 3 apples in each row multiplied by the number of rows, 4. And once again, 3 times 4 is going to be 12. So the first method of multiplication, repeated addition. The second one is to line them up so that they make a rectangle of sorts. And then what you do is you count the number or indicate the number of apples or objects in each row, and then you multiply it by the number of rows that you have. Over here on the next screen, we're going to take a look at it a little bit further. Illustration here. This time, however, I removed the apples, but we're still going to use our 4 and our 3 that we had on the previous page, the previous screen. Now, if we take a look at this rectangle here, we can see that there are 3 columns, 1, 2, 3, and then there's 4 rows, 1, 2, 3, 4. And that's what this 4 indicates here, that there's 4 rows on this side of the rectangle, and this 3 here indicates that we have 3 columns on this side of the rectangle. So then, if we were to go 4 times 3, another way of illustrating it is to have a rectangle whose dimensions are 4 and 3. 4 being the length of one side, 3 being the length of another. And when you multiply 4 times 3 together, how many different squares does that then give you? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we see that 4 times 3 is 12. And the reason why I wrote 12 on the inside here It's just to indicate the answer. Didn't matter which specific box or where I put it. The exact location isn't necessary. I just put it in here to indicate that the answer is 12. 4 times 3 is 12. There's your rectangle with 4 on this side. There's your same rectangle with 3 on this time. 4 side, 4 times 3 is 12. Here, I've just taken it one step further and I've removed the grid lines. So all we're looking at here now is a simple rectangle. The length of this side of the rectangle is 4. The length of this side of the rectangle is 3. And if you remember your basic formula for finding the area of a rectangle, it's length times width. So if we're going to go 4 times 3, that's the same thing as saying a rectangle whose length is 4 and whose width is 3. Well, what is 4 times 3? Well, it's the same 12 that we had in the previous example. So this 12 on the inside of the rectangle indicates the area of the rectangle, and then the two sides being 4 and 3. 4 times 3 equals 12. Now, down here, it's a little bit different. Here, we still have a rectangle, and the length of one side is 7, but the length of another side is not an exact number. It's a variable instead. It's an unknown number. We don't know what that number is yet. So it's been assigned a variable. In this case, it's been assigned the letter x. Now, going through with our same system for illustrating multiplication, one of the ways of illustrating it is through a rectangle, that when you're multiplying two numbers together, it's the same thing as having a rectangle whose lengths are those two and then multiplying them together. So my question is, if my length here is 7 here and x on this side, what's the area? Now remember, we don't have an exact number here, so we're not going to be able to get an exact answer. But if you use the illustration, our answer is going to be this times this. Our example up here has 4 times 3. So what's our answer going to be down here in this rectangle? It's going to be 7 times x. 7 times x. So the area of this particular rectangle is 7 times x. We don't know what x is yet, but we can still represent the area as 7 times x. Now, can you see a potential problem? Do you see how our multiplication symbol that I used here, an x, is very similar to our variable of x? They're a little bit different in size here, but because these two are so similar and would cause a lot of confusion, in algebra we never use the letter x or this small cross to indicate multiplication, to erase that confusion when you see it next to a variable x. So I'm going to go ahead and erase that. And the way in algebra, when you have a number being multiplied by a variable, you simply put the number first and the variable second, and you stick them right next to each other. So this is pronounced 7x, and what that really means is 7 times x. Now, when you're multiplying two numbers together that are exact numbers, for example, 7 and 11, there's a couple different ways that you can write that multiplication problem. Remember, in algebra, from here on, we are not going to use the letter x to represent our multiplication symbol. So what are our choices for symbols? Well, first one is a raised dot. So if we were to put a raised dot about halfway up between the 7 and the 11, if you put it down here on the bottom, it could get confused with a decimal point. That's why you raise it up about halfway. So that raised dot in algebra means multiplication. So this is 7 times 11. Another way of writing multiplication in algebra is to use parentheses. So if we put a parentheses around the 7 and put another parentheses around the 11, and there's no other symbol in between those parentheses, that means to multiply. So 7 in parentheses times 11 in parentheses. That's the same thing as 7 times 11. They mean the same thing.